So how does the methodology work? Well, I said in an earlier slide that we can work with any liquid as long as it contains a hydrogen atom, because we're going to look at essentially the protons in that liquid. Now, the hydrogen atoms in a liquid behave a little bit like magnets. So we've got a little diagram here showing the hydrogen atom, a liquid molecule with a north and south. So in the absence of any applied magnetic field, the orientation of these protons, these little magnets, are random. And the net magnetic field is, of course, zero. When we place a sample into the Acorn area, what we're essentially doing on the picture on the left, and we show here, is we have two permanent magnets and we have a coil. And so the sample tube containing the concentrated suspension is placed inside that coil, which sits inside the magnetic field. The green discs are permanent magnets, and the field is called B0. So when a sample is inserted into the cassette, the liquid protons align in the direction of the field. And this process takes only a few seconds. So we see here now we have the field B sub 0, and all the protons of the liquid are aligned. Now what we do on that coil, we apply a very short RF pulse, B1, and the protons then the proton magnets now rotate in the direction of B1, and in our instrument we set it to be 90 degrees to the magnetic field. So all the protons now basically orient in the direction of this applied field B1. When you then turn off this short RF pulse, the magnetic field disappears. And what happens is the protons then relax, rotating back to align with B sub 0. Now, when dipoles basically rotate or move in a coil, they will induce in the coil a voltage, and we get, in fact, a decaying voltage signal shown in the graph on the right. The blue lines is the fit to the red dots, which are the actual data points itself. And from this, we're going to measure what's called the relaxation time, and that's what we're going to use to probe and interrogate the nature of the wettability of liquids for surfaces itself. And the total typical time for a single sample is often less than a minute.